Hey class, in today's lesson we're going to talk about properties of logarithms, which is found in section 3.3 part 1. Our objectives are to rewrite logarithmic functions with different bases and to use properties of logarithms to evaluate or rewrite logarithmic expressions. So the first thing we'll talk about is change of base formula. So it says you may occasionally need to evaluate logarithms to other bases. To do this, we can use a change of base formula. So sometimes we may need to change it to base b, meaning it's two logs that have a common base. And so we may choose a base, and base b just means any base. So it could be like base 11, base 12, base 3, it doesn't matter. It's just some common base. Base 10 is changing it, and this is a little bit more common. You'll typically choose base 10 because that way you can use your calculator. And then the last one is base e, which is actually your natural log, and that allows you to use the natural log in the calculator. Just notice the setup, and then that's how we will change our bases in the following problems. All right, in example 1, we're going to change the bases using common logs. So the way we'll do this, we'll use a common log base of 10. So that'd be log base 10 of 30 over log base 10 of 4, which will yield in our calculators, because you just use a log button, that would be about 2.45. With log base 2 of x, since we have a variable, we'll still set it up the same way as log base 10 of x over log base 10 of 2. However, what we want to do is we want to break that fraction up into multiplication by two fractions. So that'd be 1 over log base 10 of 2 times log base 10 of x over 1. Okay, and what that would do, 1 over log base 10 of 2 actually is an answer, and then we would just multiply it times log base 10 of x. So 1 over log base 10 of 2 is really 3.32 log base 10 of x. And that's our final answer. In example 2, we're going to change base using natural log. Again, we will still get the exact same answers had we done this with natural log, or at least they'll look very similar in their standing. So log base 4 of 30, I could do the same thing similarly with natural log of 30 over natural log of 4. Okay, that would be about 2.45. All right, the last one, log base 2 of x. Again, we'll split this up as the natural log of x over the natural log of 2. But that becomes two fractions as 1 over the natural log of 2 times the natural log of x. 1 over the natural log of 2 is 1.44, and then we just attach the natural log of x. And that is our answer. The only difference between this second answer and what we got the last time is the use of natural log versus log base 10. But and essentially, remember, natural log is really log base e, which is at 2.718, blah, 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 whatever. And log base 10 is just log base 10. So it's a little different in the way it looks as an answer, but as values, they are the same. Just some heads up about how we deal with properties of logarithms. So with multiplication, if you have a log base of something that's being multiplied together, you can separate it using addition. Same thing with natural log. If we have division, we will separate it using subtraction. And then if we have powers, what we will do is we will take that power. So if you look at the third one, that n, we would then move the n to the front. Okay, so powers just move to the front. Okay, we'll take a look at this in our example 3. So in example 3, if we have the natural log of 6, they want us to write these logarithms in terms of natural log of 2 and natural log of 3. So natural log of 6 is the natural log of 2 times 3. And since it is 2 times 3, we will then write our final answer as the natural log of 2 plus the natural log of 3. Just remembering that multiplication means addition when we want to expand it. Okay, the natural log of 2 over 27 is the natural log of 2 over 3 cubed. because I really should write it as 2 over 27, but 27 is 3 cubed. And since it is subtraction or division, it becomes subtraction, so that becomes a natural log of 2 minus the natural log of 3 cubed. And then finally, because it's 3 cubed, has a power attached to it, I move the 3 to the front of that natural log. And so our final answer becomes a natural log of 2 minus 3, the natural log of 3. And then our last problem says use properties of logarithms to verify that negative ln of 1/2 equals the natural log of 2. So negative natural log of 1/2. So let's go ahead and break that down. So I need to write this to where it looks stacked. Otherwise, it looks a little confusing. Okay, so 1/2 is really 1 over 2 to the first power. So what made it a fraction, if I take it out of fraction form, it becomes a negative exponent. So this is now negative natural log of 2 to the negative first power. Then we'll take this negative first power and move it to the front. So this becomes negative 1 natural log of 2. And a double negative makes a positive, so natural log of 2 equals what we were trying to prove, which is natural log of 2. Sorry that ended up sideways, but anyways, that's our answer. Okay, guys, we are done with this lesson. If you have any questions, please be sure to come see me for tutoring.